Imagine a world where traveling to space is as simple as taking an elevator. No rockets, no massive fuel costs, just a smooth ride into the stars. It sounds like science fiction, but the idea of a space elevator could be the future of space exploration. Space exploration has always been limited by the high costs and technological challenges of launching payloads into orbit. But now, the concept of a space elevator presents an exciting solution. By using advanced materials and cutting-edge engineering, a space elevator could offer a more affordable and efficient way to transport people and cargo into space. In this video, we'll dive into what a space elevator is, explore its potential applications, and examine the challenges that must be overcome to make this ambitious idea a reality. A space elevator is a proposed structure extending from the Earth's surface into space, allowing vehicles to travel along a tether without relying on traditional rockets. The design features a cable anchored to the Earth at one end, extending into space at the other, with a counterweight positioned beyond geostationary orbit to maintain tension. The idea behind the space elevator is simple yet revolutionary. Instead of using brute force to overcome Earth's gravity, the elevator relies on centrifugal force to balance the gravitational pull. By tethering a cable to a fixed point on Earth and extending it into space, vehicles can climb the cable using mechanical systems like climbers or elevators, powered by electricity or other propulsion methods. To grasp the potential benefits of a space elevator, it's crucial to understand the basic principles of gravity, centripetal force, and mechanical advantage. Gravity pulls objects toward the Earth's center of mass. In traditional rocket launches, overcoming this force requires a massive amount of energy, which drives up the cost of space travel. A space elevator, however, leverages a counteracting force called centripetal Earth's surface into space and attaching a counterweight beyond geostationary orbit. The elevator creates tension in the cable, balancing the gravitational pull on the system. The key benefit of a space elevator is its ability to offer a mechanical advantage over traditional rocket launches. Instead of using massive amounts of energy to directly overcome gravity, the space elevator utilizes Earth's rotational motion and the tension in the cable to lift payloads into space. This method requires far less energy and resources, leading to lower costs and much greater efficiency. Unlike rockets that need to carry fuel into orbit, a space elevator operates using renewable energy sources like solar power. The climbers or elevators that travel along the cable are powered by electric motors or other propulsion systems, consuming far less energy than conventional rocket engines. This sustainable approach to space travel lowers environmental impact and reduces the long-term costs associated with traditional rocket launches. One of the biggest advantages of a space elevator is its potential to drastically reduce the cost of space travel. Traditional rocket launches are incredibly expensive due to the large amount of fuel needed to escape Earth's gravity. In contrast, a space elevator could significantly lower the cost per kilogram of payload, making space more accessible for scientific research, commerce, and more. Unlike rockets, which use vast amounts of fuel and produce harmful emissions, a space elevator operates on renewable energy sources like solar power. This sustainable approach to space travel aligns with the increasing focus on environmental responsibility and could lead to a cleaner, greener future in space exploration. Another advantage of a space elevator is its ability to transport larger payloads than conventional rockets. With the right infrastructure, the elevator could carry not just satellites and scientific instruments, but also habitats, factories, and other structures needed for long-term space colonization. This increased payload capacity opens up a multitude of possibilities for expanding humanity's presence beyond Earth. Building a space elevator presents major challenges in material science due to the extreme conditions and requirements of the structure. Overcoming these challenges is essential for ensuring the project's safety, reliability, and feasibility. A key challenge is developing materials with an exceptional strength-to-weight ratio to handle the immense forces on the elevator cable. Traditional materials like steel are too heavy and prone to failure under tension. Advanced materials such as carbon nanotubes offer great promise due to their strength and low density, but scaling up production and maintaining quality are significant hurdles. The space elevator must endure various environmental factors, such as temperature fluctuations, radiation, and micrometeoroid impacts. These stresses can weaken the materials over time, creating safety risks. Developing materials with enhanced resistance to these factors, like advanced composites and nanomaterials, is crucial for the elevator's long-term durability. Ensuring the fatigue and fracture resistance of the materials is another challenge. The repeated stress cycles on the cable can lead to fatigue failure, and any defects in the material can increase fracture risks. Advanced manufacturing techniques, such as additive manufacturing and defect detection systems, are essential to address these issues and enhance the overall reliability of the space elevator. Nanotechnology offers promising solutions to the material science challenges in space elevator construction. Carbon nanotubes, known for their exceptional strength, stiffness, and resilience, could be key. Ongoing research into nanomaterial synthesis and processing is crucial for scaling up production and reducing costs. Collaboration among researchers, engineers, and industry stakeholders is vital for overcoming the material science challenges of building a space elevator. Sharing knowledge, resources, and best practices can accelerate innovation. International partnerships between academia, government, and the private sector can leverage diverse expertise to tackle this ambitious project. Constructing and operating a space elevator will raise environmental and regulatory concerns. Issues like space debris mitigation, orbital congestion, and international cooperation need to be addressed to ensure sustainable space infrastructure management. Additionally, concerns about space militarization and the need for arms control agreements could complicate efforts to fully realize the space elevator's potential. One of the biggest challenges is the economic viability of the space elevator. While the long-term benefits are clear, the initial costs for research, development, and construction are substantial. Securing funding from governments, private investors, and international organizations will be crucial to move the project from concept to reality. The concept of a space elevator offers tremendous potential to revolutionize space access and open new avenues for exploration, commerce, and colonization. By leveraging advanced materials and innovative engineering, we might one day see a towering structure connecting Earth with the cosmos. Despite the significant challenges, the potential benefits are immense, making the pursuit of a space elevator a valuable endeavor for the future of humanity's journey beyond the stars.